All right. So let's go through another solving problem, and then we have 4 proofs that we're going to be doing. In number 5, we want to find the measurement of angle LMN. Let's go to the picture. Here's L, here's M, here's N. So we want this angle right here. And we want to do this in such a way that angle A, not angle A, line A, would be parallel to line B. So I want this line here parallel to this line here. If I want line A to be parallel to line B, I need an angle that touches both lines. What lines touch this red angle, LMN? What lines touch angle LMN? Line B touches it, and line C touches it. Neither of these lines is A. I need an angle that touches A because I want these lines to be parallel. Is there an angle up there that touches line A? Which angle? RST, yes. Here's R, down to S, over to T. What kind of angles are these two? They're not vertical because they don't touch each other. Remember, vertical shares a vertex. Are they interior or exterior angles? They're alternative exterior, or sorry, not alternative, alternate. That's my bad. Alternate exterior angles. And if lines A and B are really parallel, then what relationship do those alternate exterior angles have to each other? Are they congruent or are they supplementary? They are congruent. Remember, supplementary means they add to 180. Congruent means they are the same size. So we have that angle RST is congruent to angle LMN. What did we just use to set that up? What kind of angles did we say these were? Alternate exterior angles. So I can set up that congruence by the alternate exterior angles converse. If I know that two angles are congruent, what do I know about their measurements? They are equal. So the measurement of angle RST is equal to the measurement of angle LMN. What did we just use there to be able to make that statement? We knew that they were congruent, and now we're saying that means their measurements are equal. What are we using? Definition of congruent angles. Well, how big is angle RST? Yep, 9x minus 12. How big is LMN? 4x plus 6. What did we just use? Substitution. All right, now we're going to solve this for x. That means I need to get my x's on the same side. Subtract 4x from both sides. So that would give me what? 5x minus 12 equals 6. What did we just use right there? Yep. Subtraction property of equality. What do I do now? We add 12 to both sides. That would give me what? 5x equals 18. What did we just use? The addition property of equality. What do I do now? Divide both sides by 5, which is using division property of equality. What is 18 divided by 5? 3.6, using my division property of equality there. Is that what they wanted me to find right there? They want us to find the measurement of angle LMN. So the measurement of angle LMN. What did they tell us at the beginning was the size of LMN? 4x plus 6. So how do I find this now? We're going to plug in 3.6 in the place of x. So 4 times 3.6 plus 6. How big is angle LMN? 20.4 degrees. This is an angle, so we're going to put degrees on the answer. I did not put degrees with x because x was not an angle. All right, I promise there's a reason why I made you give me the reasons for each step we were taking, and that's because the very next problem we're going to do is a proof where we have to give reasons for every single step that we're taking. So let's look at number 6. We're going to start walking through that proof. You with me, Thomas? That would be a negative. All right, we're getting ready to start this problem right here. What is the first statement that I want to make? Angle A is congruent to angle H. And why am I allowed to make that statement? Because it is given. So this right here. What do we want to show in the end? Line V is parallel to line W. Do we already know that those lines are parallel? No. We know that angle A is congruent to angle H. These two angles right here are congruent, but I don't know that these two lines are parallel. I'm going to have to show they're parallel, and it's telling me that my very last reason here is the corresponding angles theorem converse. Does anybody remember what the corresponding angles theorem converse says? Corresponding angles theorem converse tells me that if I have two angles that are corresponding angles and they are congruent to each other, that means the lines are parallel. If I can find corresponding angles that are congruent to each other, then that proves that the lines are parallel. So I'm going to have to find some corresponding angles up here. I need to find an angle that's either corresponding to A or to H. What's an angle that corresponds to either A or H? E. E. Corresponding angles, one interior, one exterior, matching corners. These two angles are corresponding angles. So if I can show that those two angles are congruent, if I can say angle A is congruent to angle E, then that would prove that my lines are parallel. Do I know already that those angles are congruent? No, I don't. We were told at the beginning that A and H are congruent. I don't know that my corresponding angles are congruent because I don't know that my lines are parallel. If I already knew the lines were parallel, then I would know those two were congruent. But I don't know the lines are parallel. I see another angle relationship up here, though, that'll let me say this. Angle E and angle H. What do you know about angle E and angle H? They're vertical angles. Angle H is congruent to angle E. You said they're vertical angles, so what would we use to say they're congruent to each other then? What kind of angles are they? Vertical angles, so what can we use? Vertical angle theorem. We're going to use our vertical angle theorem to say that those two angles are congruent to each other, which I'm allowed to say even if there's not parallel lines, because vertical angles are always congruent to each other. Well, I said that angle A was congruent to angle H. We were given that. And I know that angle E is also congruent to angle H because of the vertical angle theorem. So are angles A and E the same size? Yes, using what? Substitution or transitive property. This is a perfect example of what transitive property looks like in action. We have A congruent to H, the same thing that we ended with here, H congruent to E. So we have the same thing twice. And so I can take these two and set them congruent. I would call this transitive property, but I would accept if you said substitution.
So our notion is that we're still using theorems and properties of equality that we did on the. I don't know if it was the previous module.
It is. All of these just build on each other. Anything that we've done in the past is fair game moving forward. All right. And then by the corresponding angles theorem converse, we can say that these two lines are parallel. We just proved something. What kind of angles are A and H? Alternate exterior angles, yep. We just proved the alternate exterior angles converse. Alternate exterior angles converse. All right. Let's look at number 7. This one, I apologize for this. This box right here should be filled in on your page. We're going to go ahead and fill it in. I'm going to give you this reason. We're going to use the converse, corresponding angles theorem converse, just like our last reason was. Corresponding angles theorem converse.
So with the abbreviations, can we abbreviate on the test, or do we have to have those?
You can abbreviate on the test. However, whatever you're abbreviating, you've got to make sure that it's clear what you mean. Just like we talked about on the last one, SUB, you can't use SUB property because I don't know whether you mean substitution or subtraction. So you got to be really clear in what you're meaning. Give me enough letters that I can figure out what you're abbreviating. Because if I can't make it out, then it's wrong. All right, so I'm giving us this one. We're going to fill in all the rest. What would my first statement be here? Angle 6 is congruent to angle 3. And why can I say that? Because it is our given. Let's go mark that on the picture. Here's angle 6. Here's angle 3. What do we want to prove in the end? That J is parallel to K. Line J parallel to line K. We know our reason in the end is that we're going to be using the corresponding angles theorem converse. And again, we know that because I gave us that one. So I'm going to have to find an angle that corresponds to either 3 or 6. Can you give me an angle that is corresponding to either angle 3 or angle 6? Angle 2 or angle 7. Which one do you guys want to go with? We just have to pick one. 7. Sounds good. So angles 3 and 7 are corresponding angles. If I can show that these corresponding angles are congruent, that will prove my lines are parallel. So I want to make that statement. Angle 7 is congruent to angle 3. I don't know why I can say that yet, but I know I want to make that statement. I know that angle 7 is the same size as what other angle up here? Angle 6. Angle 6 is congruent to angle 7. And why do I know that? What kind of angles are they? Vertical. So what are we using? Vertical angle theorem. Well, I know that 6 is congruent to 3, and I know that 6 is congruent to 7. So why could I say that 3 and 7 are the same size? What'd you say? Transitive property. I don't know they're congruent. I'm trying to show that they're congruent. We know they're congruent because of what we set up above and the transitive property. If 6 is the same size as 3 and 6 is the same size as 7, then 7 and 3 have to be the same size as each other by the transitive property. And because I know that 7 and 3 are congruent, I know that the lines are parallel by the corresponding angles theorem converse. We just proved something. What kind of angles are 3 and 6? They are alternate interior angles. We just proved the alternate interior angles converse. Very nicely done. All right, we have 2 more proofs to go. Let's go over to page 13 and finish this out strong. They filled in a couple of the reasons for it, or sorry, statements, not reasons. I know what my first statement needs to be. Yes, K is parallel to W, and X is parallel to T. I even know why I'm allowed to say that. Because it is given. I think I can finish out all the statements. Don't I know the thing that we're going to say last? What are we going to put there? Angle 11 is supplementary to angle 4. I don't know why I can say it yet, but I know that I'm going to say it. All right, let's look at the picture. We know that K and W are parallel because we were given that. And we know that X and T are parallel because we were given that. And then let's look at this, because they gave us the next statement that 11 and 13 are supplementary. Well, 11 is right here, and 13 is right here. What kind of angles are those? Consecutive interior angles. Do I already know that the lines are parallel? Yeah, they told me right there, K and W are parallel. So I know these two lines are parallel. That means I know that these angles are supplementary by the consecutive interior angles theorem. Okay. So I know that 11 and 13 are supplementary. That's great. And then it says that 13 and 4 are congruent. Well, what kind of angles are 13 and 4? Corresponding angles. Do I already know that these two lines are parallel? Yes. Since I know the lines are parallel, I can use my corresponding angles theorem to show that they are congruent. Okay. I know 13 and 11 are supplementary. I know 13 and 4 are congruent. I want to say that 11 and 4 are supplementary. Well, that looks almost like my statement here in step 2. What's the only difference between my statement in step 2 and where I'm ending? Yeah, we changed the 13 to the 4. Are 13 and 4 the same size?
Yes.
So can I make this replacement?
Yes.
Using what? Substitution. Nicely done. We've got one left to do. It's got 5 steps and we've got 5 minutes. I think we can pull this off. We might not need to use all 5 steps. We're going to see. I know what my first statement should be, though. Yes, L is parallel to M, and S is parallel to T. Why can I say that? Because that is the given. What do I want my last statement to be? Angle 7 is supplementary to angle 12. So I'm going to put it down here at the bottom, although if I don't use all the steps, it might bump up a little bit. Angle 7 is supplementary to angle 12. Let's go find those. Here's angle 7, and here's angle 12. Do they touch the same line? No. Do I already know my lines are parallel? Yes. I was told that S and T are parallel. I was told that L and M are parallel. So I need to find something that's the same as either 7 or 12 so that we can have some lines in common. I don't want to do vertical angles because 6 doesn't have anything in common with 12 either.
No,
4. 7 and 4 or 12 and 4?
4 and 12 because
They're matching corners. What do we call matching corners? Corresponding angles. So I can say that these two angles are congruent. Angle 4 is congruent to angle 12 by the corresponding angles theorem. All right, so 4 and 7 touch the same line. What do I know about 4 and 6? They are consecutive interior angles. And what relationship do consecutive interior angles have with each other? They're supplementary. So angle 4 is supplementary to angle 6 using my consecutive interior angles theorem. Well, doesn't that mean that 7 and 4 would be supplementary? Because 7 is the same size as what? 7 and 6 are the same size because they're what kind of angle? Angle 7 is congruent to angle 6 because they are vertical angles. All right, let's see what we can do. I want to say that 7 is supplementary to 12. Here I showed that 4 was supplementary to 6. But what's the same size as 4? 4 and 6 aren't the same size. 4 and 12 are the same size. What's the same as 6? 7. So I can replace 4 with 12. I can replace 7 with 6. So what's my last reason here? That's my last statement. What's my last reason? Substitution. All right, listen up, guys, before the bell. That homework that you just picked up on your way in the door, we have finished everything now. That one is due on Monday. Your test is on Wednesday, so I can't make it due on Tuesday. You have all weekend to get that homework done. Please bring it with you finished on Monday. Homework is due on Monday. Oh, thank you. I can take that when we come out. Thank you.
have a good weekend.
Thank you, you too.